Today, we're cutting through all the hype to see how artificial intelligence isn't just some far-off concept in medicine. Nope. It's a powerful tool that's being used right now to predict illness, to solve really fundamental problems, and even to offer a second opinion on your x-rays. So, let's get into it.
Just think about that for a second. What if you could get a heads up from your own body analyzed by an algorithm that tells you something's off long before you even feel a thing? This isn't science fiction anymore. This is the new reality of predictive healthcare.
So here's our roadmap. First, we're going to look at AI's incredible ability to predict what's coming. Then we'll pop the hood and see the foundational tech that makes it all possible. After that, we'll look at AI in action today, and finally, we'll talk about what all this means for the future of your health.
Okay, let's start with that AI crystal ball. We're talking about systems that can spot patterns that are totally invisible to the human eye, seeing these faint signals of what's to come for our health.
7 weeks. Just let that sink in. That number comes from a groundbreaking study at Mount Sinai. It's how much advance warning an AI could give someone before a flare-up of inflammatory bowel disease, or IBD. Think about it. That's nearly 2 months to get ready, maybe change up your treatment, and possibly avoid a really severe episode.
And you know what's really wild? It's how they're doing this. This isn't some complex, invasive procedure at a hospital. The data is coming from the stuff we wear every day. Apple Watches, Fitbits. The AI just continuously tracks our body signals, analyzes these tiny shifts in our daily rhythms, and from that, it can tell the difference between actual inflammation and, just an off day. And they proved this with over 300 patients, so this is the real deal. And this superpower isn't just for inflammatory conditions. Nope, researchers are using the very same ideas to tackle one of our biggest health challenges, figuring out the long-term risk of developing diabetes. And for that, just look at the amazing power of a new model called GlueFormer. In a 12-year study, it sifted through blood sugar data, and honestly, the results are staggering. The AI sorted people into risk groups, and get this, 66%, that's 2/3 of all new diabetes cases came from that top risk group it flagged. Meanwhile, only 7% came from the bottom group. The takeaway? The AI is exceptionally good at spotting who's most at risk. And it does this by just chewing through a massive amount of data. We're talking over 10 million measurements from glucose monitors. But here's the kicker. The same model that predicted diabetes risk also flagged 69% of cardiovascular deaths in that same high-risk group. This isn't a one-off thing. It's been proven to work across all sorts of different people in 5 different countries. It's incredibly powerful.
So, we've seen what these incredible AI models can do. Pretty amazing, right? But now, let's go into the engine room and understand the breakthroughs that actually give AI these superpowers in the first place.
It's a totally fair question, isn't it? I mean, how do you go from just a bunch of code to something that can understand the complexities of human biology? Well, the journey is pretty fascinating.
It actually starts not with biology, but with pure logic. It's about pushing AI to its absolute limits, teaching it to reason at the same level as the smartest humans. A perfect example is Google DeepMind's AlphaGeometry 2, which was trained to master a field that is all about pure logic, advanced mathematics.
I mean, this system is now performing at a gold medal level. It's solving 84% of these super hard geometry problems from the International Mathematical Olympiad. It uses this really cool system that kind of combines a creative neural network with a classic logical reasoner. So while it's crushing math problems today, the skill it's learning, creating flawless logical arguments, that's the exact foundation you need for really reliable medical imaging and diagnostics down the line.
But as these AIs get smarter, they run into a very human-like problem. They forget things. In the AI world, they call it catastrophic forgetting. You teach a network something new, and poof, it completely wipes its memory of what it learned before. And this has been a huge roadblock in creating AI that can really learn and adapt like we do.
So what do? Well, researchers are looking to the ultimate expert on memory, the human brain. Your typical AI is prone to that catastrophic forgetting, but this new brain-inspired model, it can hold on to both the big picture and the tiny details. It can learn new things on the fly without being told what to do, and, get this, it does it all using way less power. This is a massive leap forward for creating smarter, more efficient AI for, well, pretty much anything, especially medicine.
Okay, so we've gone from looking way into the future to the deep tech behind it all. Now let's bring this right back to the here and now with a super practical example of AI acting as a partner in diagnosis.
This is a question that feels like it's from the future, but for some people, it's already here.
What happens when you take a publicly available AI, like the ones you can use right now, and give it a real medical image to look at?
So one person actually did this. After a nasty fall and a trip to the hospital for x-rays, they were told they'd have to wait a while for the radiologist's official report. So they thought, I wonder what ChatGPT would say. And they uploaded the x-ray.
And the difference was just night and day. The traditional way meant waiting around, feeling uncertain. The AI method, it spit out a really detailed analysis of the x-ray in seconds. Now, let's be super clear. This is not a replacement for a doctor, but wow, it is a powerful demonstration of how AI could totally change our experience as patients, giving us immediate insights or even a potential second opinion.
Okay, so let's tie all of these threads together. We've gone from long-term predictions to the deep tech, and we've landed on a real-world use case. So what's the big picture? What does this all mean for us?
The revolution we're seeing is really a journey from prediction all the way to practice. It kicks off with these amazing models that can forecast our health future. What's powering that is all the foundational research, making AI smarter and more stable. And all of that comes together in practical tools we can start to see and use today.
The researchers at Mount Sinai really just said it perfectly. This isn't just about cool new tech. It's about a huge shift from reactive medicine to proactive, personalized healthcare. A world where we can manage health instead of just treating sickness. That's a monumental change.
And all of this leaves us with the really big question for the future. As these tools get more powerful, more common, and more reliable, we're all going to have to ask ourselves, how much of our health, our well-being, are we willing to put in the hands of an algorithm? It's a question we're all going to be answering a lot sooner than we think. Thanks for watching.